welcome to This Explainer. Today, we're going to draw out exactly how your Python code talks to the outside world, and just as importantly, how it listens. Do you remember your very first hello world moment? You know, that absolutely magical instant when you typed out a few characters, hit run, and suddenly, boom, a string of text appeared right there on your screen. Well, that was your very first conversation with a computer, and today we are going to unpack the nuts and bolts of that conversation from absolute scratch.
So here is our roadmap for building your very first calculator today. We'll start with how the computer speaks, move on to listening to the user, navigate the dangerous string trap, use typecasting to the rescue, actually build that simple calculator, and then finish up with a quick recap of common mistakes.
All right, section 1. The computer speaks. Let's master the print function, which is really how a computer articulates its very first word to the outside world. Now, the crucial point here is that the print function is the literal voice of your program. It converts raw data into a nice, readable format for you. In modern Python 3, it's a built-in function, which means it always needs parentheses. You just pass something into print, and it instantly gets formatted for you to view on your console or terminal. It's essentially the primary way your program communicates what's going on inside its brain to us human users.
But what's really interesting is that the print function isn't just some simple megaphone for plain text. Sure, you can output static text using single or double quotes, like printing "Hello World," but you can also tell it to evaluate math on the fly, literally just typing print, parentheses, 2 plus 2 to instantly get 4. You can even chain totally different variables together, just separated by commas. So if you have a variable for a name and a variable for an age, you just separate them with a comma, and Python automatically jumps in and inserts a space between the items, making your output incredibly clean.
Moving right along to section 2, listening to the user, featuring the input function. Because let's be honest, a good conversation is always a two-way street.
The input function works like a set of very clear instructions. First, it pauses the program. Then, it asks a question, waits for the user, and finally saves that response so we can use it later. When Python hits an input command, your entire program literally freezes. It's actually a pretty cool aha moment to realize your code just stops and patiently waits for you. It displays whatever prompt you gave it, like "What is your name?" and only wakes back up when the user types a response and hits the Enter key. And most importantly, it captures that typed response so you can assign it to a variable and use it anywhere else in your code.
Okay, section 3, the dangerous string trap, miscommunications in Python. Now pay attention, because this is where absolute beginners hit their first major roadblock.
So imagine you ask a user for two numbers to add together. They type 10, and then they type 10 again. But instead of giving you 20, the computer gives you this ridiculous answer of 10, 10. I mean, what? Why does this happen? It feels like the computer is completely broken, right? But actually, it's following its own internal logic perfectly.
This perfectly illustrates the string trap. You see, the input function always captures a user's keyboard strokes as text strings, so adding them just glues the characters together instead of doing the actual math. Python is inherently safe and incredibly literal. It doesn't assume you want to do math unless you explicitly tell it to. Even if the user types the number 5, the input function sees it purely as the text character 5. When you put a plus sign between two text strings, Python performs what's called string concatenation. It just slaps the two pieces of text side by side. So 5 plus 5 just becomes 55. To the computer, it's literally no different than adding the word apple to the word pie to get apple pie.
Which brings us to section 4, typecasting to the rescue. It's time to learn how to translate data types to fix this whole miscommunication. By using explicit type conversion, or typecasting, we can force those text strings into actual usable mathematical numbers. This is where we step in as the translator and explicitly tell Python, hey, look, I know you captured this as a string of text, but I really need you to treat it as a number right now. We use specific built-in functions to force this conversion, ensuring our data is in the exact right format before we try to calculate a single thing.
So here is your translator's toolkit. The int function turns text into whole numbers, float handles decimals, and string converts things back into text. If your user types 6, passing it through int makes it a real mathematical 6. But if they type a decimal, like 3.2, you absolutely must use float because an integer simply cannot hold decimal points. And sometimes, you need to go the other way. If you have a calculated number and need to combine it strictly as text, the str function turns that number right back into a plain string character.
Section 5. Building a simple calculator. Let's bring this whole shebang together. Now we have all the building blocks, speaking, listening, and translating. to sketch out our mini project.
Notice how you are taking complete control here. First, you politely prompt the user for input. Then, you use the float function to safely convert those string answers into decimals. Next, you add them up. And finally, you use print to declare the final total. In steps 1 and 2, the program pauses, asks for the numbers, and stores the user's text inside the variables num1 and num2. In step 3, we avoid that string trap entirely. We wrap num1 and num2 in the float function to convert them to numbers before the plus sign does its job. And we use float instead of int just in case our user wants to add decimal numbers. Finally, in step 4, the computer speaks back, seamlessly mixing our text and our final calculated variable.
Section 6. Recap and common mistakes. Navigating errors is just a completely normal part of programming. Let's look at what happens when things don't go perfectly to plan.
Seriously, don't panic if you see a scary red value error or type error pop up on your screen. If you run your new calculator and type the word apple instead of a number, the float or int function is going to crash. It will throw an exception, literally letting you know that it cannot convert a piece of fruit into a mathematical base 10 number. Your code isn't fundamentally broken. Your computer is just being very literal. These errors are completely normal speed bumps. It's just the computer's way of asking you for clarification.
So, let's wrap this up. Mastering input and output fundamentally means controlling the conversation. You speak clearly using the print function. To gather information, you pause the program and capture user responses safely with the input function. Most importantly, you always cast your strings using int or float before you attempt any math to avoid that tricky string trap. And remember, hitting a value error isn't a failure. It just means you are actively learning exactly how the computer interprets data.
You have officially conquered the basics of Python input and output. But I want to leave you with an exciting problem to solve on your own. How will you expand your conversation to give the user the power of choice? Right now, your code strictly adds. Using what you now know about printing prompts and capturing input, how might you ask the user what kind of math they actually want to do next? Think about it, keep experimenting, and keep the conversation going.